Our final speaker of the session is Lori Glaze, and she's going to give us an update on NASA's Planetary Science Division.
Fantastic. I want to thank you all for inviting me here today. It's an incredible honor to be here, particularly in this year. There's so much exciting stuff going on. I mean, it would have been exciting enough with just all the lunar excitement around the country and around the world, but then with the Apollo 50th on us as well, what a great opportunity to be here. And I have to say, I'm sure everyone in here is excited as I am about our field trip this afternoon. I know I can't wait. As I said, it really is an incredible time to be a planetary scientist, and really just to be even a scientist within NASA. And it's an incredible honor for me to have the opportunity to be taking on that leadership role in Planetary Science Division. But within all of science within NASA, these are the top three areas, the big questions that we're trying to answer through kind of interdisciplinary and cross-divisional activities, trying to answer these major questions in science. What are the secrets of the universe? Discovering those secrets, trying to look for and identify places where there could be life beyond Earth, or what types of environments could sustain that life. And then thirdly, trying to protect and improve life back here on Earth. And planetary science has a really important role in all three of these areas. And so we have, as I said, an incredibly exciting time right now. These are the fleet of missions within the Planetary Science Division that are trying to answer those big questions across those three big themes. And I don't have time here today to talk about all of these fantastic missions. I'll hit a couple of highlights. But the one thing to point out to this group in particular is that we now have a moon box, which is a lot of fun, that we have enough going on at the moon that we've started adding a moon box. And of course, in there is Lunar Reconnaissance Orbiter, which is going strong after 10 years. I'm sure Steve spoke at length yesterday about the CLPS program, the Commercial Lunar Payload Services. And so we've got those activities going on with new landers, we hope, launching over the next couple of years and beyond. We also have a lot of international discussions going on. And in fact, I wanted to say I was really excited to see Maria's talk before this. One of the things that makes all of this lunar exploration so exciting is that it's not just happening in one place. It's happening all over the world. There is so much excitement internationally, commercially. It really has, it feels like we're at a point where we're really going to make some major advances, not just in science, but in human exploration as well. So we're on the cusp of some really, really good stuff going forward. Wanted to just put this picture up here for a moment to just reflect on the incredible legacy. We're all sitting here. Jack gave a fantastic talk this morning on some of the key science results from Apollo. But just to think forward to the legacy of that mission and the Apollo 11, but going forward through all the Apollo missions and the legacy of that and how that's played forward into how we think about doing planetary science. These Apollo missions were really the first planetary science missions, the first time we actually went off of our own planet in any way to really do core science. And I think it's important to reflect on that. We still have legacies of these here today with the sample return missions that we have going now, trying to bring samples back from across the solar system, and other types of missions as well. I love this particular picture because it shows one of the first things that we did on the moon was not necessarily plant the US flag, but we planted a science flag. And this flag right here, of course, if you don't know, is a solar wind experiment to collect solar wind. And this is a statement for international science, and no one country owns this. We all own the incredible science results that come from these types of experiments. So I wanted to just give you a few updates on some things going on within Planetary Science Division related to lunar activities. There are some efforts going underway at the moment working with the Astra Materials Curation Group at Johnson Space Center to do a variety of things, one of which is we started off working on something called MoonDB. It's now evolved into AstroDB. This is an activity to catalog and collect in a database information on, it started out as lunar samples, but now all the astromaterial samples, petrologic and geochemical information. And this website, this database is now up and operational. It's currently populated with information from the literature, but it's available for the entire community to input your information, which will help to make more information about the samples that we have available to the entire international community. So encourage people to check it out, look and see what's in there, and see what you can contribute from your own scientific endeavors. Another activity that was funded by PDART, another one funded by the PDART program, is the Astromaterials 3D project. And I've checked out this page. It is really cool. They have the first rock up. It's amazing. You can see very high precision, high definition imaging of the first rock in every angle. Rotate around, see up close. It's as if you're sitting there holding the sample in your hand. And in addition, then they also have X-ray tomography that allows you to sample all the way through the inside of that rock. It is really an amazing website with an amazing capability there that allows you to feel like you're actually holding that sample in your hand, looking inside, and hopefully we'll get additional rocks added to that soon, new samples. It's a great resource. And in thinking about going forward, we're hopeful with all of the excitement about getting back to the moon, both robotically and with humans. We'll get some new samples. But in thinking about that, now that we have new information where we believe there's water ice or cold samples there that could contain some type of water, we want to be able to keep those cold, and so we'll have to have some types of special storage facilities, and we're in conversations with Johnson Space Center now and the Astromaterials Group on how we're going to do that. And then with those new samples coming back, opens up a great opportunity to go back and look at some of the original samples that we have. And I'll give a shout out to Jim Green, who actually initiated this program, the ANCSA program, which I was lucky enough to inherit when I walked in the door. But it's a great opportunity to, as Jack says, use as he mentioned, be able to use the new techniques and the new analyses that capabilities that we have now, in addition with the new hypotheses that we have now, new knowledge that we now know about the moon. We see a different moon now than we did 50 years ago with new information about the water that's present and its distribution on the surface. So these pristine samples offer a great opportunity to go back and relook and learn more from those samples. As you said, Apollo will live on for years and years as we learn more and more from these samples. So 9 teams were selected in the spring that are helping to define exactly how we're going to open this Apollo 17 sample and what types of analyses are going to be done. And so you'll be hearing a lot more about that coming up. The tube that they've selected, that's been selected, this Apollo 17 drive tube, the non-sealed upper part is going to be opened in the coming months, and then the sealed portion we're still working on with all the teams on exactly how that is going to be done. I'm sure that Steve spoke a great deal yesterday about the Commercial Lunar Payload Services Program, so I'm not going to spend a lot of time talking about this. But the thing I really wanted to focus on here is from my perspective, from the lunar science perspective, this CLIPS program really offers an amazing opportunity to us as scientists to have frequent and regular access to the moon to conduct lunar science. And so I'm really excited about all of the different programs here where we're investing in instrumentation, a broad variety of instrumentation, as I'm sure Steve mentioned, including technology demonstrations and instruments that are going after the key knowledge gaps, all types of science instruments that can be conducted to do science from the moon. But I'm particularly interested in those that are doing lunar science. And so we have these programs here, the NASA Lunar Payload program, the NPLP, the LSIP, which is the selecting instruments from non-NASA sources. We have DALI, which is investing in newer instruments that need to be raised up to a higher technology readiness level, and hopefully will be within a couple years at a level where they could fly on future missions. We have another call for Dolly this year. There were 10 selections last year, and the step two proposals are in for this year, and we received at least 40 proposals in June, and are in the process of reviewing those now. And so again, really excited about the ability to invest in these lunar science instrumentation capabilities to help prepare us for when we do have that frequent access to the surface, that we're prepared with the right payloads to do the science that we want to do. The Lunar Data Analysis Program, the ROSES 18 proposals have been submitted and are in review now. Interestingly, we didn't see a huge increase in the number of proposals to LDAP, but what we have seen is healthy numbers of selections in some of our other core programs that are lunar-focused science. And so I think there is still a great deal of good lunar science being proposed and selected and funded. But certainly encourage people to take advantage of LDAP. Make sure you pay attention to those deadlines and get your proposals in. We're also in the process of reviewing proposals to the Korean Pathfinder Lunar Orbiter mission. And so those are in review now, and looking forward to participating in that endeavor. Again, as I said, so much international interest in the moon, not just from the traditional agencies that have had interest in the moon, but from emerging space-capable nations, which is really fantastic news. And then the last thing I mentioned on this particular slide is the survey teams. We have a fantastic organization here with Survey. Really enjoyed my interactions that I've had with Greg and with the team and with Yvonne in the past. A fantastic organization, great teams here that provide a lot of important capability to the agency in their abilities to use the teams to be mobilized to answer questions directly or to organize workshops and things that can be directed at trying to pull the community together to provide information to the agency. Two examples there are the transformative lunar science and the lunar landing sites, but I feel certain they will be tasked much more as we go forward into the future with more exciting things to do. So speaking of Survey, again, I probably won't spend a lot of time. I don't know how much time Greg spent talking about the new teams yesterday. But I wanted to just speak for a moment about, from my perspective, what I see as the important role that Survey plays. Again, the ability to mobilize the teams. We've got fantastic teams with diverse capabilities and diverse interests that really try to bring together different ideas from around the community that can help feed the knowledge hunger within the agency. So right now, there are 12 to 13 overlapping U.S. teams. There are the 9 that were funded in CAN 1 are starting to roll off. There's 4 remaining from CAN 2. And then there's 8 new selections, which I'm going to walk through in just a moment, just to give you a flavor of those. But they really each bring some diverse new capabilities to Survey. And the one thing I want to mention is that I'm really excited about with this particular Survey selection of the new 8 teams is this is truly a joint selection between Planetary and human exploration. We have a great partnership with human exploration and work together through the whole solicitation process and selection process hand in hand to make these selections. So I think we have a great institute here that's moving forward in a positive direction with a lot of good teams. I'll mention there's some flags along the bottom there. There's hopefully going to be a new one added tomorrow. So just as a little plug, if you want to be here bright and early tomorrow, I'm looking forward to exchanging some letters of agreement with JAXA, the Japanese Space Agency, and adding them to this list. So very excited about the international participation in Survey and looking forward to adding a new partner tomorrow. So real quickly, I'll just walk through some of the 8 new teams that have been added and their new capabilities that are being added to Survey. I'm not going to read all of these because it will take me all day, but I'll just give you a highlight. So Dan Britt and his team here are bringing their capabilities for looking at regolith of the moon and asteroids. Jeff Gillis-Davis is working on an investigation of how things weather in space. We've got Tim Glotch, who's our host here this morning, who is looking at how planetary environments impact human health, and this is going to be, of course, of increased interest as we go forward and start thinking about a sustained human presence on the moon or in space, and how that environment's going to interact with us. Jen Helbin, looking at what volatiles are available for in situ resource utilization, so not just recognizing that the water is there, but how are we actually going to get at it and make use of it going forward. Mihai Harani and his team looking at these micrometeorite capabilities, looking at the impact of these dust particles with his facility, a unique facility that can look at these very, very fast impacts of small dust particles, bringing that capability, which is a great resource for the community, and looking at these processes. Rosemary Killen, who's looking at plasma interactions on airless bodies and continuing some of the work of the DREAM team that was there before. David Kring, he's looking at the distribution and form of volatiles from the early solar system to the moon formation. And this really has a lot of implications, not just for lunar science, but really for our whole understanding and story of early solar system formation and evolution. So fantastic to have that capability on the team. And then we've got Nick Schmer, who is bringing what I think is probably some relatively new and unique capabilities to Survey with his geophysics background and geophysical perspectives, which is a great complement to the rest of the teams that are part of Survey. So really excited about all of these additions to Survey and looking forward to interacting with you guys going forward. So I wanted to talk a little bit about some of the other things going on within Planetary Science Division. First off, I want to talk a little bit about Simplex. Simplex is our small mission line that was advertised or solicited last summer with a cost cap of around $55 million. This is another great thing that I inherited from Jim. He and his group did most of the work before I walked in the door, and then I walked in and there was the Simplex call ready to go. Lucky for me. It is a fantastic program. One of the keys of this program has been that these are not technology demonstration small sats. These are not CubeSats that we're just trying to show that we can get out in space. These are actual science missions, and each of the missions that were proposed had to have real science that was compelling. And what we weren't absolutely positive that at $55 cost point we were going to get real good science missions, but we had a dozen proposals, and really at least half of them were really outstanding proposals that were doing some fantastic science across the solar system. So really, really excited with the proposals that came in, and with that nice sample from which we could choose, we were able to select 3 missions to go into Phase A-B. So what this means is we are going to fund these 3 missions for a year, and they will progress through a Phase A and then a Phase B, and at the end of their Phase B, they will conduct what's called a preliminary design review. And at that point, we'll look at each of them and see whether or not they're viable for flight. 2 of these missions, I'll mention in just a moment, had proposed to fly on the Psyche mission, which is a mission to fly to the metal asteroid Psyche. And one of them, the lunar mission, actually proposed to go from geostationary transfer orbit. So they're not as dependent on a specific flight. But we'll look at these all in about a year when they get to their PDR, look at their technical readiness and their maturity. We'll look at the proposed flight opportunities and identify whether they can actually fly. Now, I will tell you, one of the things that's even more cool about this opportunity is that we only promised to select 1 for flight. But just to get you a little excited and to support your colleagues that are developing these missions, Through cooperation with the Lunar Discovery and Exploration Program, which Steve Clark leads, and cooperation with the Heliophysics Division, we actually may have the opportunity to fly all three if they can all show the maturity that they can fly. So we're trying to enable that possibility. They all have to show they can meet the maturity, though, so help them out there. But one of the things, here's the three missions that we selected. Escapade, which is a mission to go to Mars and fly 2 small sats to Mars. So if you're familiar with the MAVEN mission, which is doing aeronomy and measuring the magnetosphere of Mars and atmospheric escape, this is similar to that, but instead of 1 spacecraft, there's 2, and they'll, with the 2 spacecraft, be able to tease out the temporal and spatial variations in that atmospheric loss. So first, the 2 satellites are flying on the same side of Mars, but at different altitudes, and then over time, one of them shifts around to the other side, so then you've got one in front of Mars and one in the tail, and we can, again, try and tease out all of those spatial and temporal differences. And that particular mission is led by Rob Lillis out at UC Berkeley. The second one is Janus, or Janus, depending on what side of the Atlantic you're from. And Janus is a mission, again, to fly 2 small sats to 2 different binary asteroid systems. So with this mission, there would be the possibility of actually gathering information and collecting new data on 4 small bodies within the solar system, near-Earth asteroids. So an incredibly compelling idea about thinking about how we can do these types of small body explorations in the future with smaller spacecraft that could be maybe ready to go and just sent out when we have viable targets. So this is an interesting opportunity. This one is led by Dan Shears at University of Colorado. And then lastly, but not leastly, is Lunar Trailblazer, which is led by Bethany Ellman at Caltech. And the core instrument on this mission for Lunar Trailblazer is an instrument for trying to characterize water distribution on the surface of the moon. It's a derivative of the M-cubed mission, M-cubed instrument. I see Carly over there, so it's a kind of next generation version of that instrument, incredibly capable for mapping out water distribution on the surface of the moon. So really, really exciting mission there as well, and hopefully of interest to this community here. One thing that I find, again, interesting about this selection of small sats is that these are all new PIs. So this is opening up new ground and new opportunities to train other individuals within our community and expanding the opportunity space for PI-led missions. So again, I see this as a great opportunity there as well. I want to mention New Frontiers. Because this is our most recent selection. Of course, New Frontiers is our biggest competed category within planetary science. These are billion-dollar class missions, the largest PI-led missions that are led by the agency. And so this is a big deal. These are big missions. They're complicated. Prior New Frontiers missions, of course, are New Horizons and Juno and OSIRIS-REx. All 3 missions doing extremely well. But these are not easy missions to build and fly, and this next one isn't going to be an easy one either. We're really reaching out and going for it with this one. The selection that was made here, there were 2 missions in competition. One was Caesar, which was a comet sample return mission, and the other was Dragonfly. And the one we selected is Dragonfly, which is an octocopter to fly to the surface of Titan, which is the moon of Saturn. And it is a really exciting mission to do some amazing science on the surface of Titan. It will be able to fly on the surface of Titan and visit multiple locations over a distance of about almost 180 kilometers within its base mission, being able to characterize multiple geologic units on the surface of Titan and looking for the types of environments that would have been present in early Earth when life was first forming. So it gives us an opportunity to see a window back in what those environments were like and how life may have come to be on Earth, and see whether or not there are actual biomarkers on Titan that may indicate that life tried to form there as well. So a very exciting mission. We're looking forward to working with them going forward. And then the next opportunity, as I said, it is an exciting time to be in Planetary. We have so many opportunities, and this is yet another. So Discovery is our smaller class, competed class, which is about $500 million missions. And the most recent missions that were selected through Discovery were Lucy and Psyche, which are 2 missions to explore some of the asteroids within the solar system. Lucy visiting multiple asteroids in Jupiter's orbit, the Trojan asteroids, and then Psyche, as I mentioned earlier, to visit a metal asteroid, Psyche. So the Discovery call went out in the spring, and proposals have come in. They were due July 1st, and we are now fully in the throes of trying to get those reviewed with the intention of trying to get the Step 1 selections made by the end of this calendar year. So I know we got quite an exciting array of proposed ideas, and looking forward to that. And I had a note here just to mention that Tom Wagner has now taken over this program. It used to be run by Michael New, who was extremely able, but we lost him to a higher cause. And Tom Wagner has joined us from the Earth Science Division, but he is an amazing scientist and an amazing individual and doing a fantastic job of running that program. Okay. I want to speak a little bit about future opportunities and trying to grow the next generation. As I said, I'm really excited about the Simplex selections, in part because we are tapping into new parts of our community that haven't traditionally led these types of missions before. But in addition to that, this is an area that Thomas Zurbuchen, who is the Associate Administrator for NASA Science, is really committed to trying to not just encourage, but to support diversity and inclusion across our scientific community. We all believe and sincerely that we achieve excellence by making sure that we have teams that bring multiple diverse ideas to the table. And so we want to do what we can to help encourage that and to support those diverse teams. Part of that is attracting and retaining the talent by promoting that culture that's inclusive and diverse, and helps to remove the barriers to participation, and things like these simplex calls or those types of activities that can bring in new opportunities. Also encouraging development of our future leaders, and encouraging the next generation of mission principal investigators through targeted outreach and hands-on opportunities. Supporting our early career scientists to build careers working within NASA, and then engaging the general public in NASA science, because that's where it all starts, is trying to engage those learners at a very young age and beyond to bring them into our NASA fold as we go forward. So speaking about the NASA Principal Investigator development in particular, this is something that, again, Thomas is very keen on and has been working on at the Science Directorate level at NASA. He's working very hard to try and bring down what the barriers are that are out there, and to that end, last November he held a workshop and invited several early career scientists across all the science disciplines to come participate. And it was an interesting discussion, not all positive, but the good thing that came out of it was a lot of great ideas to help find ways to make information more available and to help the early career scientists in the community. Some of these things were to develop a consolidated PI resource page, which has now been set up and is available. Also to introduce pre-reviews for all of our panels to make sure that we are really ensuring that we don't have implicit biases and some kind of barrier to the diversity in those panels that might play through in evaluations. We've added a code of conduct to the requirements for S&D funded conferences and the ROSES 19. We've restarted the proposal writing workshops at major science conferences and included career development positions and associated evaluation criteria is part of the new calls, and actually Discovery and New Frontiers have been leading the way, and the other divisions are actually now starting to follow this, where there are requirements on these missions, large mission proposals, that the PIs include a deputy PI with one being mentor, one being mentee, to help encourage the development of new PIs in our pipeline. The AA, Thomas, actually gave a colloquium back in June, which is, I believe, archived online. You can check it out, Writing Successful Mission Proposals. When he gave this talk, I think there were a couple thousand people that streamed it live. It's really an outstanding presentation, and encourage people to check it out. It was a good, had a lot of good resources in there. And then upcoming activities, looking for some information sessions at science conferences. There's going to be some workshops to be held that are focused workshops with more smaller participation for real engagement, and so those will be coming up. If you're interested, you can check out that website. And just a couple more things before we go. I wanted to talk a little bit about the future and where we're going. First, the midterm. So within the Planetary Science Division, we request from the National Academies a survey of the community and of science priorities every 10 years, our decadal survey. And we're a little over halfway through our current decade, which runs from 2013 to 2022. And so the National Academies conducted a midterm evaluation to see how well we're doing against our decadal survey. And that came out last fall. And within that, some of the key findings of that midterm evaluation were that the academies continued to stress the importance that we try and maintain or achieve a 24-month launch cadence for our Discovery program. This has been a long-standing challenge to meet that. That is a very demanding schedule. But in the last Discovery call, there were 2 selections, as I mentioned. And this seems to be hopefully a good path forward, is to run a solicitation for Discovery every 4 to 5 years with the intent to try and select 2 in each of those to maintain that average cadence on the order of 2 to 3 years. As I said, a challenge, but we're going to try and do that. New Frontiers. Within the New Frontiers program, as I said, we just made a New Frontiers 4 selection. But the decadal midterm has recommended that we run that next New Frontiers call as soon as possible, but at a minimum no later than 5 years after the New Frontiers 4. We are not quite on target for that, I will be honest. I believe that the New Frontiers 4 call came out in December of I'm going to get the year wrong, 2015, I think, and it was either 14 or 15. But we're probably not going to get the target would be 2020, and we're probably going to get the call out in sometime in 21, according to the budget phasing that we have now. But we're trying as close as we can to meet that target. The midterm did say that we are largely following or exceeding the recommendations for RNA funding and technology funding, which was recommended at a level of about 6 to 8%, and that we are maintaining that, which is good, and we're going to try and keep that up. Certainly, all of the technology funding that we've invested this last year in lunar instruments is going way above and beyond that 6 to 8%, I think. So we're doing well there, at least in this year. And then the last recommendation was that we should sponsor 8 to 10 mission concept studies to help us prepare for the next decadal survey. The next decadal survey will be kicking off next summer, about a year from now. And so there was that recommendation that we conduct some studies to help look at various larger mission concepts that could be potential future flagship missions or future New Frontiers targets. And so we are, in response to that and other Academy's recommendations earlier, starting that preparation. We had a call for planetary mission concept studies that went out in the spring with proposals due at the end of May. We have all those proposals in hand, and we are actively reviewing those proposals. These are for potential mission concepts. And as I said, those are being reviewed, and the results from those Those reviews will be the selection of 8 to 10 teams in the fall that will then begin hopefully a 9 to 10 month study to look at various mission concepts. They'll have funding to bring scientists together to think about what the science traceability should look like, what the science goals are, and how that traces down to a mission architecture. And then funding will be provided to a NASA center, either to JPL or Goddard or APL, to run the engineering studies that can support those architectures. And the reports that come out of those studies will then be available and provided to the National Academy's Decadal Survey, which, as I said, is going to kick off next summer. So we're very excited about that. I think we got some clever and unique and interesting ideas through that solicitation call, and it'll be interesting to see how these come forward and what we're able to go forward with. As a last note, I would mention that we got way more proposals than we'll be able to select through this process. So just because someone's concept doesn't get funded through NASA for these concept studies doesn't mean they aren't great ideas. And I encourage people to work through the standard National Academy's white paper process. If for some reason your idea didn't get picked or you didn't put in a proposal through this call, there is that opportunity to write up a white paper and submit that to the Decadal Survey for their consideration. And that's certainly a viable path as well. And I can tell you, as someone who was on the Decadal Survey last time, we read every single white paper. So send them in. But when you think about writing white papers, just another caveat, encourage you to work with your community members and your colleagues. Fewer papers with more endorsements have more impact than hundreds of individual papers written by individuals. So just keep that in mind as you're thinking about coordinating different papers to submit to Decadal Survey. Would encourage that. So with that, I think I'll shut up and stop talking and take some questions.
Hi, Barbara Cohen, NASA Goddard. Lori, I appreciated your discussion about encouraging early career scientists and all the work that you and Thomas in particular have been doing with that, and that's really important, and it's really great to see that commitment. However, you know that the genesis of that workshop was not how can we bring early career scientists into the fold. So I think there's a little bit of a conflation between diversity and inclusion efforts and early career scientists. Early career scientists are a part of our diversity and inclusion efforts, but they are not the total. And something that Thomas said in his talk, which was interesting, was no one lost more than me. He lost a lot of proposals, and he said, you know, keep at it and keep going, and eventually you'll get there. But there's a whole segment of the community who don't get to propose. They've already lost. They've been run out of the community, or they've been harassed and they don't get to propose. Okay, so there's a whole segment of diversity and inclusion efforts that really has to go beyond providing more information so that you can write a better proposal, if we're not even getting to the point where those people can write proposals. So can you talk a little bit more about the additional efforts? For example, the Hubble Space Telescope Institute did a really comprehensive look at how bias may have been creeping into the review process, how it could be corrected. Are we doing anything along those lines?
So I'm so glad you brought that up, Barbara. In fact, yes. So, and you make a really good point that yes, number one, early career is not all of diversity and inclusion. It must be much broader than that, and you are absolutely correct that we have to find ways to reduce barriers beyond, right, to help find individuals that are not even making it to that first part. So you mentioned the Hubble Space Telescope. So what Space Science Institute did was they ran an experiment, a double-blind, dual anonymous review process on some of their observation proposals. And they had some really interesting conclusions. Now, there's still some more work that needs to be done on it, but the initial results that they got showed that they really were able to eliminate some of the biases that we bring to the table by doing this dual anonymous, where you didn't know who the proposers were, you didn't know what their institutions were, and it was really, I saw the presentation from the team, it was very compelling. So what I can tell you is we are exploring looking at a dual anonymous test case within Science Mission Directorate in the coming year. In fact, we're all looking at, each division is looking at their different ROSES portfolio to identify a potential candidate to try and look at this to see if we can number one, assess the impact of bias that plays in our review process, and then number two, to continue to try and work to remove as much of that bias as we possibly can in the review process.
That's really encouraging. Thanks, Lori.
Thanks. Jim?
So I just wanted to make a comment on this particular topic that's very important. Ellen Stofan initiated a demographic survey that was connected to submitting proposals into Inspire. And those statistics now are being analyzed by my organization. And in fact, in the last town hall, we went at AGU. We have a town hall that we're going to establish every year at AGU on Meet the Chiefs. You know, the chief scientists at all the centers are part of that. And we went through the statistics we had. Okay, and some of the things that we're looking at particularly is, you know, we talk about bias, but what are the metrics? What are the results? What are we trying to really look at? That comes through the demographic material. So I want to encourage everyone, please don't ignore it. You can, but don't ignore it. Really fill it out. That helps us really take a look at things like bias. For instance, we look at the number of males and females that are proposing, and then the number of males and females that are selected, okay? And that's an element of potential bias, a measurement of what a bias might look like if there's more males or more females, for example, that win or lose, depending on how that goes. Those statistics are really important. We want to continue to collect them, and once again, we'll be talking about them at the Chiefs Town Hall at the AGU, so everyone will see the results.
That's great, and it's a good point that that's voluntary information, but keep in mind that, you know, that the use of that is really to help us try and make things better. I also wanted to mention that we're hoping, and I don't have specific information on this, but to do a community culture survey run by the AIP before, as part of the decadal process, to try and get a pulse on where the key issues are within the community. Yeah, so we're working that, and it'll either be through the individual divisions, or we're actually trying to do one that goes across all of the science directorate to get a real sense of the broader community. Okay. Emma?
Okay, hi, Amanda Hendricks, PSI. On the topic of diversity and inclusion, you know, the efforts at headquarters are great. It's great to see you guys working on improving possibilities for mission PIs. But another area that I think could use some diversity is current missions. And one way to increase diversity and also just get some fresh blood is participating scientist programs. And I believe that there's, you know, at least a handful of missions that have been flying for like 10 years and have only had one PS program. So I wonder if there's any opportunities for additional PS programs for current missions, and what your thoughts are even about, you know, future missions.
That's a really good point. I mean, and I absolutely agree with you that the participating scientist programs are a fabulous way to add and bring new blood into a mission, but not just that, it brings in people with new ideas that can combine the measurement observations from these missions in new ways that haven't been thought about by the team, or the team is focused on delivering their data to the PDS and writing their papers, but, you know, bringing in the PSPs allows that to expand. So I absolutely agree with you. We are trying to make sure we have PSPs. I will go back and look at some of the older missions. That's something that I, in all fairness, have not actually, I don't have the date on the top of my head, but I'll go back and look and see what some of the older missions that maybe don't. But
My understanding is that some of these current missions would love to have more participating scientists, but they don't
Yeah.
have the resources to do so. So I don't know,
Right.
how that would be handled, but it
right.
just
Well,
seems like.
just and also just as a caveat to everyone in the room, resources are not unlimited. And so at the end of the day, priorities have to be set, right? And so I will just say the same thing to this crowd that I say to everyone, and this is not necessarily in response to Amanda's question. This is a more general statement in thinking about resources that we have within the division and how priorities are set and where the funding goes, right? Because we cannot support everything. There's too many good too many good things to do out there. So I will tell you, same thing I tell everyone, that when I'm setting priorities and making funding decisions, my priorities are the competed mission lines, so Discovery and New Frontiers, making sure that we can do everything we can to try and meet the decadal recommended cadence as close as we can. Number 2 is the RNA program, because I think RNA program is the backbone of what we do. RNA, the research and analysis is the work that builds on the observations that we already have. It helps us to build the new hypotheses that drive the next set of missions. And planetary science, unlike the other divisions within NASA, NASA is the only game in town for planetary science, almost. I mean, we are almost the entire funding for planetary science community, and so I feel that our RNA program is even more important than most. So just so you know, that's high up on my list. And then, of course, coming in also in that top tier is making sure that the missions that we are building, that we're committed to, that we can actually get them delivered on time and hopefully within cost as best we can.
So I'm going to make a request for more resources for something.
We can keep asking. I will tell you, though, in this last year, we've got more funding than we've ever seen ever for planetary science. And it's still challenging because with that more funding comes more cool stuff to do. So just so you know, I mean, it continues to be a challenge even with the additional resources that are coming in.
Absolutely. So going back to the points that Barb and Amanda made in addressing the topic of diversity and inclusion, physics and geosciences, which are 2 of the core disciplines within planetary science, have the lowest representation of African Americans, Hispanics, and Native Americans among any of the STEM disciplines. In the past, NSF has had specific program elements for increasing diversity in the geosciences, for competing proposals for university faculty or other private institutions to actually build programs to try to address that diversity. I think they could potentially be a successful model for NASA to do something similar. I think right now, if you don't live in an EPSCoR state, there's not really anything that we can do to actually try to put resources behind that. So I'd like to just encourage you to take a look at that. At Stony Brook, we did get one of those NSF programs, and we built a successful program, and I think it could be something that would be done on a much wider level.
Yeah, I'm really interested in learning more about that, Tim, so maybe we can have a sidebar.
Happy to.
And as you said, I'm very familiar with EPSCoR, and of course we do try and work with EPSCoR to come up with projects and ways to help bring in the underrepresented parts of the country. But as you say, if you're not in an EPSCoR state, that's not an option. So I definitely want to learn some more from you on that.
Thank you.
Thanks.
Hi, Parvati Prem, APL. So another note on diversity. So Laurie, you mentioned that NASA, as the primary source of funding for planetary science research, has an important obligation in making sure there's diversity in the RNA programs. But particularly within this community, the community of people involved in lunar science in particular is expanding to include people working in the commercial sector and the private sector. And I know NASA can't solve everything, and this is based on admittedly anecdotal evidence, but it seems to me that the community we have engaged in these discussions about establishing a sustained presence on the moon and the private sector's role in that is a lot less diverse than even the planetary science community as a whole. And again, I know NASA can't solve everything, but I just wanted to bring that to attention. And I think it's something we should, all of us, be keeping in mind, is how we can encourage broader participation in that conversation as well.
You make a very good point. I will not disagree with you on that. I know what you're saying. Thanks.
guess I'm the last one, and I like to bring the conversation a little back to science as well. And I love some of the graphics that you've been using. I don't know if anyone in this room noticed it, but one of the first slides you showed, to me, showed how lunar science, and in particular the Earth-Moon system, is so fundamental to all of solar system science in so many different ways. And the slide I'm thinking of is the one that you had at the beginning that had the 3 crescents sort of interwoven. And those crescents, to me, are lunar crescents. And it highlighted the way that lunar and, in particular, Earth-Moon science is so fundamental in everything that solar system does. So I just like to leave with that, and maybe that wasn't intended, but for me, seeing the crescent moon interwoven into everything was really the way it is.
I agree with you, Carly. Thank you. And as I said, I think certainly, as I said, the lunar program from the 50s and 60s and into the 70s really drove our thirst for exploration and for science, and certainly the lunar science laid the foundation for what we understand about how the solar system formed and the chronology and our understanding. So we build on each other, right? That the science drives the exploration, and then what we learn from exploration drives more science. So I think it's a fantastic partnership.